So this isn't going to be like an on-duty philosophy talk in the sense that I'm not going to try and defend some very specific claim with the kind of close argument that we normally do for kicks at philosophy conferences and so forth. I'm going to try and sketch a picture. And so this is a bit, there's an argument there, but there's here, or there will be, but it's something of a sketch. And so, yes, I'm talking about science, talking about the collaborative nature of good reasoning. And I'm going to start by talking about, for a little while, about Paul Feyerabend, who is undoubtedly one of the most famous philosophers of science of the 20th century. He wrote a number of books. Probably the most famous one is his book Against Method, which uniquely among philosophy of science books has the property that I once fell out of bed laughing while reading it. If there are other books like that in philosophy of science, I haven't found them. And he was a very controversial and also playful figure. His background included a lot of theatrical training and so forth, and he controversially defended some of the time a view that he called epistemological anarchism. Well, he called it various names, but that was one of the names. And he's one of the list of kind of go-to philosophers, even now, by people who are keen to criticize science. Right? There's a little list of go-to philosophers. He's one of them. Thomas Kuhn gets wheeled out sometimes as well, very unfairly, and despite the fact that he knew practically nothing about science, so does Richard Rorty. But I'm going to start with Feyerabend. And in a book that he wrote a while after Against Method called Science in a Free Society, because someone else has broken the ice with swearing already, I should mention that in his autobiography, he expresses regret about Science in a Free Society and says that sometimes, quote, I wish I'd never written that fucking book. But what he's referring to mostly there are the entertaining but incredibly grumpy responses to the reviews of Against Method. But there's also an essay in it called Science in a Free Society, and in that he says, well, there are two questions we have to ask if we're having any kind of discussion about science. What is science, and what is so great about it? And he ducks question A. He doesn't really have a developed answer to it, but he has an answer to the second question, what is so great about it? Spoiler, the answer's nothing. But he's got an argument for that answer, which I want to use as a kind of extreme contrast to then sketch a view that I think is much better. Right? So Feyerabend says there's nothing great about science. He says arguments from methodology do not establish the excellence of science, nor is science preferable because of its results. And what he says in defense of both of those claims is entertaining but incorrect. So on the results claim, I think it's very, very easy to dismiss what he says, right? Partly he rigs the contest in his own favor by sort of rhetorically insisting that in order for us to admire science because of its results, it has to be the case that things other than science have no epistemic achievements at all. Sorry, I say epistemic to mean knowledge. It's just a professional thing. It makes me sound pretentious, but it's just the word I'm used to saying. So when I say epistemic, I mean relating to knowledge. Okay, so that's a false dichotomy. And then it also depends on just the straightforwardly incredible claim that I'm not going to waste time on, but maybe we can come back to in discussion, that science prevails not because of its comparative merits, but because the show has been rigged in its favor. This from someone who actually knew the history of the Galileo episode. So I don't think we need to worry about that. But what about the methods claim? Well, here, I mean, and here's the nub of what Feyerabend says, with a lot more fireworks and sarcasm and jokes. There is no scientific method. There is no single procedure or set of rules that underlies every piece of research and guarantees that it is scientific and therefore trustworthy. So I think there are lots of things we can say about that way of framing the issues, but I think it just sets the bar too high, right? Why should there be a single method that gets used in all of science? Why should it be used in every bit? Why should we think that what it would confer, rather than some kind of competitive advantage would be a guarantee, right? All of that's contentious. And we need a better model, right? And I'm going at a gallop, so I won't spend more time on that. But here's a better model. And I didn't choose it because we had another speaker with a very similar surname. One of my favorite philosophers, British-born, but she works in Florida, Susan Hark, written books on a variety of topics, but largely centered on epistemology and philosophy of science. And I would say if you were going to only in your life read one general philosophy of science book, I would make it that one, her 2003 book, Defending Science Within Reason, which also includes her taking on and taking down Feyerabend and Rorty and others. And she says something which I think is true. In fact, I think everything in that book is true. She says the core standards of good evidence and well-conducted inquiry are not internal to the sciences, but common to empirical inquiry of every kind, right? What it is that, when it's done well, criminal detective work involves, or the work of a historian who may even be professionally insulted to be called a scientist, right? And I don't mean like wacky postmodern historians, I mean proper admirable historians. That's not fundamentally different in kind, in the sense that there's some particular set of technical tricks or methods that all scientists use and that detectives and historians and people trying to work out what's wrong with an appliance or something don't use, right? So I think that's basically correct, but that's not to say that there aren't any differences at all, that there isn't something useful we can say about what might be distinctive about science. And so what follows from that? Well, one thing that follows from it is that, at least in retrospect, we can say that it was futile, even if worth trying at the time, to do what it was that was popular among positivist philosophers of science and so forth in the first half of the 20th century, which was to say what the distinctive scientific method was. Right? They thought science was a thing that had a method, the method was a thing that had some kind of logical nature, and then they argued over different models of what that logic was. Is it mostly inductive? Is it hypothetico-deductive? Is it this? Is it that? But that's not a good way to tell what science is. But that doesn't concede Feyerabend's point, right? This might seem like a dangerous concession. Feyerabend says there's nothing great about science, its results aren't impressive, which I think is a silly thing to say, and it doesn't have a distinctive method. Hark saying, well, no, it doesn't have a distinctive method in the sense of being distinctive from other kinds of responsible inquiry where we're just trying to figure out what the evidence tells us is likely to be true. So she says, yes, the sciences are not epistemically privileged in that sense of having a distinctive method, but she says they are, however, epistemically distinguished, right? They deserve our admiration for their epistemological achievements, even though those achievements aren't bought by having some distinctive method or technique. Okay. And furthermore, we can make some kind of sense, and it would be possible to talk all day about this, but we can make some kind of sketchy outline, hand-wavy sense of why this is so, right? Some of it is because science has, on the whole, more and more sophisticated evidence, right? Think about what's just being described to us. A device for gathering radio waves that in its full functional size will be thousands of kilometers across, right? We'll have a sensitivity unprecedented in the whole history of recording devices for finding out that kind of thing, right? It turns speculative questions with a whole lot of other hard work by theoreticians and so forth, it turns them into empirical questions, right? It also has, on the whole, more and more sophisticated theory, and often, especially in the natural sciences and sciences that kind of border on the natural sciences, mathematically rigorous theory, right? A lot of things that from a conversational point of view, even a quite disciplined conversational point of view, don't really have meaningful differences, can be made to have meaningful differences that might be empirically detectable if the theories are made more and more precise. Okay, and that often requires or is facilitated by mathematical regimentation. And then, and this is over long stretches of historical time, right? One can find the earliest examples, at least 2,000 years ago, powerful collections of augmentations of various kinds to the inquiry process. And that includes instruments, things like, if you could even call it an instrument. I mean, it's a giant assemblage of instruments of many different kinds, like the square kilometer array or the Large Hadron Collider or something like that, but also notational systems, ways of representing claims about abstract things like numbers, ways of presenting the annotations of theories so that people can collaborate in highly efficient ways, things like Feynman notation for particle physicists and so forth, and conventions about what to treat as at least provisionally in the bank. And I put literature in good standing because I didn't want to too narrowly plant my flag on something like peer review, and lots of terrific scientific literature is older than the invention of those contemporary institutions and so forth. I'm not against peer review, I just wanted to say literature in good standing, which I thought was a more general term. And in fact, it occurred to me earlier on, I wish I'd put it on the slide, that because it's one of those cute verbal things that kind of amuses me, partly one could reword the third bullet point there as thinking through things, right? Building structured devices that significantly increase our epistemological powers, right? And they start with relatively simple examples, early observatories, where people pick a piece of ground and start marking out the geometry of it so that they can make observations, if they follow certain rules, which are more discriminating than those that you can make with the naked eye, right? Ptolemy, over 2,000 years ago, I think, I may have his dates wrong, less than 2,000 years ago, worked with astronomical data that was more detailed than you could get by just looking with the naked eye, but without telescopes. Well, by structured ways of doing the observations, by thinking through things. And the theories, the notations, the mathematical systems and so forth do that too, right? I was sitting trying to think, what's the most recent point at which a time-traveling scientist from history would have been able to figure out approximately what the SKA was if just dumped there and looking around, right? It's pretty clear it would have been completely baffling to Newton. It would have made no sense whatsoever. Not because he was stupid, but because it embodies all sorts of findings that he just had no idea about, right? What would someone with his theory of light and no real theory of automated computation or anything like that make of it, right? I mean, I think second half of the 19th century, people would probably have worked out that it was in the light measuring business, but earlier than that, I doubt it very much. Okay, and I want to emphasize that one other feature. How am I doing for time? Oh, I'm babbling. Okay, I'm going to finish easily. One other important thing that underlies all of those other ones and is tremendously significant in its own right, and that is these things and the way they're used and the way they are maintained by institutions of a whole lot of different kinds, some of them explicitly identifiable formal bodies like international societies for zoological taxonomy or something like that, that in some abstract sense have a book which is a list of species and you get entered in it, but also ones that have less straightforwardly identifiable membership and an official list that they look after. but they permit what I like calling the division of epistemic labor, right? The division of labor of this knowledge-seeking project over space, right? Again, we were just looking at a measuring device so big there isn't a single country that it can fit in. There isn't even really a continent that it can fit in. So including national and sometimes, to a certain extent, mathematical, I mean, not mathematical, language boundaries in the case of the highly mathematical subjects, and also over very long periods of historical time. And that's a relatively more recent thing, right? It's not that long ago that someone with the right kind of training and a certain amount of funding could do fundamental physics experiments by, I'm going to say her or himself, but they were mostly blokes back then. Nonetheless, I emphasize her or himself, in a room, right? In a sense, on a bench, right? Some kind of lab bench. But for lots of questions, that time has passed, and one of the striking things, if you just look from a kind of sociological perspective, is that some of these things take such a fantastically long time, right? They're people whose names are appearing on publications coming out of the Large Hadron Collider who hadn't been born when they started building it, right? Because that's not, you can't just go down to Radio Shack, get a few bits and pieces and kind of bang it out in a shed anymore. These things are enormously complicated. They take a very long time to build, and they're utterly beyond the constructive capacity of a single person because they require many, many interlocking kinds of expertise that have to be able to make sense of one another, right? I mean, we're familiar with it with computers. We go and we buy a gadget and we plug it into a USB port and it pops up as a storage device or a display device or a game controller or whatever it is that we're into, right? There's an epistemological version of that going on. And that's not something that just happened. It has to be developed and maintained and then more or less continually at varying paces in different fields, modified and extended and adapted because new problems come up, right? Managing quantities of data that would have been pure science fiction 20 years ago is now a day-to-day problem for some kinds of working scientists. Okay, and so these conventions, and I want to emphasize one aspect of this in order to gallop to my conclusion, one of the many aspects. There's a lot to say about how it is that that division of epistemic labor is made possible and how it's maintained. But that is what I put under the heading of showing your working, right? And it's instructive, right? Those of us who did science subjects at school would have gone through some of this. Some of us will have been working scientists or will regularly read scientific papers, but I want to ask you, sort of whatever your level of engagement with that is, step back and look at just some of the generic features. And I'm mostly talking here about an exemplary empirical paper in an established field. One can make analogous arguments for what goes on in more theoretical fields, but these examples are more common and they've got enough in them to carry the message, right? Look at a typical empirical paper. Well, there's the literature review, right? That's not a trivial thing, right? I often see, grad students and people are excited because they've got ideas. You think that that's a boring pain. Why must I go to the library? I want to do science. Well, partly you have to make an argument that relates whatever else it is that goes on in the thing to the literature that's in good standing, right? You have to make an argument to the possible readers that this isn't a waste of time, partly, and show that you know that stuff, right? Then you get the description of the methods, right? And again, often when people read papers with a kind of journalistic or, what's the sexy new result, right? They found the pornography area in the brain. Let me look at the pictures from the MRI with the glowing bits and stuff like that. And it's more important than one might think in that impatient mindset to slow down and have a look at what's going on in the methods. And in a fast-moving field, for example, to look at how it is that the criteria change very quickly, right? 10, 15 years ago, you could pick 5 or 6 completely random people, stick them in fMRI machines, make them do any stupid thing you could think of, do some real garden shed statistics, and get a paper in Science or Nature, right? Now, even in a kind of third-tier cognitive neuroscience journal, there's a whole lot much more specific stuff. Even the description of the subjects, right? It was, 12 right-handed males between this age and that age with no recent history of drug abuse, and these were the ones who were left over after we applied a bunch of psychopathy screens and stuff like that, and then this is what we found. Okay, so that method stuff is partly saying, how did we get the data that we got, right? And then what data did we get, including increasingly now a presumption that the data will be available to other researchers, right? That in some sense has always been the ideal, but it's become cheaper to make it realistic, right? I couldn't ask some person in a lab on the other side of the world to send me boxes of punched cards or something like that, but I can certainly get them to email me a chunk of comma-separated data. Right, and then finally a conclusion. Okay, laying out not just the conclusion, but the sort of argumentative structure of the evidence. This is what we measured, this is how we measured it, this is why we even thought it would be interesting to try to measure such a thing, right? That's, I want to say, a kind of precondition for the division of labor, right? That's how it might be possible for students working with me to try, as we sometimes do, to join an ongoing conversation about a certain kind of cognitive psychology experiment that's mostly going on in labs we haven't been to, being conducted by people we may have only met fleetingly at conferences and so forth, is we don't need to go there. It's described in enough detail that we can try and replicate, modify, extend, and so forth. Okay, and so those conventions, right, which sometimes get lighted on in a slightly weird way by people who take a kind of radical anthropological orientation to science and think that they're just kind of membership rituals, right? People who can't do that show themselves as outsiders, and therefore they'll get ignored when they put their hand up to ask a question or something like that. Well, partly they function in those sorts of ways, but they're not accidental, right? They're kind of essential features. And I want to say very, very briefly now, by way of wrapping up, that I think with some awkwardness or with some difficulty at the margins, because everyday arguments are not really on-duty science, but bearing in mind Hark's point that the standards of good inquiry are not internal to the sciences, they're common with empirical inquiry of all kinds, I think there are some useful outlines of lessons we could take away from the scientific model, right? Reasoning explicitly and modestly. Well, what do I mean by those things? It seems to me very often when people disagree, leaving aside the sort of the real bottom of the barrel, or the outside of the barrel, or the sort of stain next to where the barrel is when you pick it up, of YouTube comment threads and News 24 and stuff like that. Very often in arguments, even arguments that are epistemic, not practical in the sense of about courses of action, right? They're about what the evidence says would happen if we did A or B. People are too concerned about the punchline, the end, and not enough about laying out the reasons, right? And that sort of that confrontational or that approximately parliamentary model has some advantages and has been interestingly institutionalized in bits of legal practice and things like that, but it's not the only model, right? There's the, here's why I think what I think. Here are the sources that sort of persuaded me and why I was persuaded, and so forth. So reasoning explicitly and modestly, if you're not willing to change your mind, you're not really reasoning at all, I'm afraid to say. Okay, and then to cultivate the ability to evaluate evidential contributions. That's horribly pretentious, I'm sorry. I must have just been reading metaphysics or something. I'm sure I could have said that more plainly. But evaluate them both independently and collectively, right? One of the interesting things to emerge from the kind of empirical study of reasoning ability, one of the very common features of people who are bad at reasoning is they don't like, and also are not very good at, a certain kind of thinking exercise of the form, what would you do if the thing you thought was true was false, right? What would you think? How would you modify your beliefs if this thing that you hold as being part of the key evidence for what you think turned out to be false, right? What would you do if it turned out that the Earth went round the sun? What would you do if it turned out that whatever, right? But that's a skill, right? It's not the case. There's no evidence to suggest that there's some gene for that and you're just born able to do it or not able to do it. It's a skill that one can cultivate. It's a skill that it seems to me the way one's brought up makes a major contribution to. How it is our parents talk to us or how it is that we talk to our children makes a big difference to whether or not that skill is developed. But that's partly what I mean by evaluating the evidence separately, right? When thinking about the evidence, set aside for a while what it means to you, how well it defends some view that you're actually quite keen on anyway, and just think about how good it is as evidence, and then go back to that collective picture, the kind of Susan Hark likes, and I think she's spot on with it, a crossword puzzle analogy, right? Sometimes you've got to think, how well does my idea for this entry fit the clue? And sometimes you've got to think, well, but what does this do to the other things I thought were good responses to clues, right? You look at the individual thing, you look at the network, and develop the ability to move back and forth between those levels. And that inevitably involves a certain slowing down, right? One of, I think, the key barriers to thinking in a disciplined way is impatience, right? Wanting to get to the end, wanting to get to victory, wanting to get to the answer, wanting to look at the picture that shows you where the pornography area is, instead of looking and going, but no, this is a dreadful way to find out anything. These brain pictures are meaningless. Okay, so slow down a bit. And I emphasize all of those things, right? The sometimes. Don't be one of those annoying people who over-pedantically lays out reasoning on some topic where it's not necessary. And the approximately, right? Learning from the collaborative nature of good reasoning in science is an approximate exercise, because the kinds of debates we're likely to have even on epistemic topics, right, where we're arguing about what's true rather than what we should do, arguing in a disciplined way doesn't make us scientists. And that table just summarizes what I've just said. It's a terrible slide, and so I'm going to stop there. Thank you very much.